Today we will define and use imaginary and complex numbers. The number I, imaginary and complex numbers. The number I is a unique number. It represents a square root of -1. An imaginary number is any number that can be written in a plus bi form, where a and b are both real numbers. B cannot equal 0 because then it wouldn't be an imaginary number. It would just be a real number at that point. And complex numbers, they're basically any imaginary or real number. The powers of I, we have I to the 0 power, which is 1, because any number raised to the 0 power is 1. I to the power of 1 is just I. Any number raised to the power of 1 is just itself. I squared is -1, because the square root of -1 times the square root of -1. You would square that, so the squared and the square root would cancel each other out, leaving you with -1. I cubed is -1 because that's the same as I squared times I. -1 times I is -I. I to the 4th power is the same as I squared times I squared, which is -1 times -1, which is of course 1. I to the 5th is I to the 4th times I. 1 times I is I. Let's look at some examples. Alright, so the first example I want to look at is negative square root 16. So anytime you have a negative in a square root, you just pull out that -1 and then leave the rest. So the square root of -1 times the square root of 16. Well, we now know that the square root of -1 is I, and the square root of 16 is 4. So our answer is just 4i. It's actually plus or minus 4i. And that's all you do to simplify these square roots. Let's look at adding and subtracting complex numbers. So this is a plus, so this is the same as 3 minus 2i plus 5 plus I. So we're going to combine like terms. 3 plus 5 is 8. -2 plus 1 is -1. So this is the simplified version. When we're subtracting, we have to distribute the negative first. So we have 2 minus 2i minus 3 plus 3i. Combine like terms. 2 minus 3 is -1. -2 plus 3 is +1. Or positive 1, yes. There we go. All right. Now, what if we had -2 times the square root of -16. So we're going to pull out our -1s, right? So now we have -1, -1, the 2, and the 16. So the -1s together, there's 2 of them, so we squared it. And then we have the square root of 2. And then we have 4 here, right? Plus or minus 4. So that's -1 times the square root of 2 times plus or minus 4. So plus or minus 4 square root 2. Because if we multiply a -1 times a positive, it'll turn negative. If we multiply the -1 times a negative, it'll turn positive. So it's still just plus or minus 4 square root 2. All right, so here we have to remember to FOIL. So FOIL, if you remember, first, outside, inside, last. So our first terms, 2 times 3 is 6. Our outside terms, I times negative, oops, that's not right. 2 times negative 5 are the outside terms, so negative 10i. The inside is I times 3, so that's 3i. And the last are I and negative 5i, so that's negative 5i squared. We remember that I squared is negative 1. We're going to combine our like terms, so this is going to be a positive 5, right? So 6 plus 5 is 11, and a negative 10 plus 3 is negative 7. All right, now let's look at some powers of I. So if we have I to the 27, or I to the 60. So what we're going to do is we're going to take whatever power it is, and we're going to divide it by 4. So 4 can go into 27 6 times, and that gives us 24. So we have a remainder of 3. So I to the 27th power is going to be the same as I to the 3rd power. And I to the 3rd power was negative I, if you remember from the chart. I to the 360 power. Well, if you divide 360 by 4, you end up getting 90 with 0 remainder. So this is the same as I to the 0 power, which again equals 1, because anything to the 0 power is 1. So again, you're going to take your power, you're going to divide it by 2, and you're going to figure out what is the remainder. When you're dividing by 4, you can get a remainder of 0, 1, 2, or 3. So you can get 1, I, negative 1, or negative I as your answer. Those are the only answers that you can get. If you would like more practice on this, you can go to IXL underneath Algebra 2 and do sections I, 1, 2, 4, and 8. See you in Zoom.